Good afternoon, everybody. My name is Fabian Garcia. As Marissa mentioned, today I'm going to be showcasing the work that we've been putting on this FY in terms of the StormSim bubble mount design and performance module. So diving straight in it, hopefully there we go. Okay, so just a quick agenda as to what we're going to be covering today. We're going to start off with a brief recap as to what's happened in FY24 and what we last presented on our previous technical discussion. Then going through what was the main driver of us deciding that we wanted to develop a UI for our tool specifically. Go a little bit into what StormSim is under the hood, just for benefit of everybody. Then we'll go ahead with a static walkthrough of the different UI panels, just so everybody's familiar with the type of information that's going to be popping up in the demo. We'll wrap it up with a live demo of the UI and how you can go ahead and create a project and evaluate it within StormSim, and wrap it up at the end with some closing remarks. So a quick recap, let's focus first on the right side of the slide, right? This was the proposed framework that we talked about in our initial technical discussion. You will notice that at the top of the process, we are setting off with selecting the different structures that we wanted to evaluate, following up with defining what are the specific metrics that we needed to extract from those for those specific structures, and specifically in regards as to using lighter datasets in the double text toolbox. Then followed by defining what storm suite we wanted to use for the whole exercise, and finally modeling the actual protection system response and trying to get a sense as to what the performance was of that specific system. And then moving as to what has been the main focus of this FY for this effort. We've basically been honing into updating and revamping all our response equations within the software and the conceptual models that we support currently for the different protection systems. There is currently publishing tied to the updating of the empirical equation and the empirical coefficients of the equations that we use within StormSim. We can share the sources to that later on. There's also been work on StormSim guidance. This is in draft form relating to how to use the software and some considerations when building a project within the StormSim software. And then some further testing throughout different partner projects, because different district partners have reached out to us that they were interested in using StormSim for their specific projects, and several team members have been tackling that on, which is great for us because we get to test out our tools and the results that we're getting out. Some challenges that we've encountered throughout the year. First off is data related. So initially we were hoping that a lot of the information that we would get from the LiDAR data sets would be sufficient enough for us to be able to get comparison metrics in terms of performance of these structures. But that didn't always seem to be the case, which made us pivot a bit as to our approach towards this effort. It just points towards us likely having to do additional modeling to be able to get those damage metrics for these systems and be able to compare against StormSim's metrics. And then the second one, obviously, is I know everybody has been impacted by this, but the DRP wave had significant impact in this effort because a lot of the PDT members took the DRP. And also a lot of the new hires that were going to come in to help with this effort sadly got canceled due to the current climate. So things have been a bit delayed and things have been shifted around. So why did we decide to develop a UI? The short answer is user experience, right? For us internally in the StormSim team, it's very simple and easy to understand, hey, we got all these files, we're going to map it this way, and we're going to tie it to this specific system, and all these outputs and simulations are related in this way. But for a new user that's coming fresh to StormSim, it could be a bit intimidating to come across an input file that has a bunch of inputs and you don't really know what do I need to populate, what is not relevant, right? So we wanted to make something that would facilitate the user's experience in creating a project, mapping out all the dependencies, but also being able to cycle throughout the different options that you have within your projects, right? So with that in mind, we'll go ahead and do a little bit of a refresher as to what StormSim is under the hood. So for those who don't remember, StormSim currently has two major workflows that it supports. One that's meant for design, or what we call StormSim Pros, which, long story short, is basically used to create hazard curves for the different structure responses, the same way that you could create hazard curves for your storm responses, so HMO, still water level, or TP. The same way that on the right side, we have a lifecycle simulation branch where we allow you to be able to evaluate the performance of these protection systems in a lifecycle context. Specifically, if you're looking into something like rubble mounts, for example, we support the computations of damage progression, which is the main comparison metric that we want to get out of this effort, right? And to getting a sense as to how good that damage progression that StormSim spits out compares against the reality that these systems are experiencing out there. So going into what the UI looks like, this is the first thing that you're gonna see when the UI opens up, right? Where basically the user needs to define the project and the different components or assets, right? In this case, whenever I say asset, what I mean is specifically an alternative that's tied to a specific protection system element, or a protection system element itself, or even the Storm database, right? Those are the assets that StormSim is managing. So don't think we're talking about infrastructure assets and whatnot. So real quick, I want you to focus on what's highlighted on the red square. This is what we call the project panel. The intent here is that it serves as the main control to defining what is the current working object in the GUI, right? What is the specific system that I'm looking at, or the specific alternative, and what simulations are tied to it and all the files that are associated to it. Additionally, we use it to define global values. So things like the confidence limits that you want to use for your specific projects, your project datum, right? As you are all familiar, a lot of the time the project is set out for a specific vertical datum, and the modeling isn't necessarily in the same vertical datum, and there are some considerations to take into account there to be able to get them into the same vertical datum. Also things like water density, gravity constant, those are things that go within our empirical equations. And the idea here is that you're able to freely switch between these different assets, either through the use of the drop-down menus or through the project tree that's on top. You can see that the alternative A right now is highlighted. If you were to have more alternatives and you were to click on it, the whole thing will be updated automatically throughout the whole GUI. This whole figure will be populated with the corresponding one, and you'll get to see that when we get to the live demo. What you see here on the bottom left screen is basically the pop-up window that comes up whenever you go through the project management tab and create a new project, right? So the bare minimum that we need to be able to define a project within StormSim is highlighted in this little box, right? Where you need to specify a project name, where you want the project outputs to go to, what's your unit system? Is it, are you using meters, or are you using feet kind of thing? The vertical datum that you want to use for your project, and the confidence limits, right? So once you define all this and create the project, things in the project panel get populated and you're able to interact with them. Next slide. Okay. So how is it that you're able to get these different assets within the GUI? Is through the use of these menu windows on top. You can see that the first one is project management. Here is where you can add things that are specifically tied to the project. So think about the protection systems that I want to include, the alternatives that I want to evaluate. If you are going to add tides or not, all that is managed through here, the same way that you can remove it throughout these menus. On the other side, you can see that we have a menu window that's dedicated to the Storm database management. Currently, the GUI only supports what's highlighted as a CHS Storm database. In other words, we directly ingest CHS peaks and time series files in .zip format. And I'll go more into details on that on the next slide. But in the final product, will also allow to ingest StormSim Storm database, meaning an already processed data set that you want to load into the UI, or even a custom Storm database, which sadly is going to put more responsibility on the user to make sure that whatever they are providing meets the required format in order for our tools to be able to interpret them correctly. So moving on to the second tab, where it's basically called a PSC tab or protection system element. The idea here is to facilitate the user's interaction with the different geometries that they are including within their project. So again, if you go through the project management menu window and we decide to add a new PSC, what's going to pop up is the window on the bottom left, where you can see based on the PSC type that you specify. In this case, I mentioned a vertical wall. The plot gets populated and the table gets populated with all the relevant parameters that need to be defined by the user in order to fully characterize that protection system element and import it into the overall UI. Very important, you can see that you have things like the alternative name and the PSC name. These are basically going to be your pointers on your project tree, where you'll be able to switch between them and keep track of everything that's associated to them. And in this case, whenever you click on the Create PSC button, once everything's populated, things in the PSC viewer will be updated, right? And you'll be able to tweak those values in the table if you wanted to. No need to go through another PSC creation window, and that will translate through all the steps in the software. Now moving on to actually importing a Storm database. As you know, we've talked about in the past, in order for StormSim to be able to do its computations, it needs a Storm suite, specifically still water level and wave parameters, HMO and TP. So what you're seeing on the bottom left is the window that pops up whenever you are importing a CHS native database, meaning I went to CHS, I clicked on a save point, and I downloaded peaks and time series files for the storm types that I'm interested in. So in this little window on the bottom left, you can see that the CHS zip folder is just, you know, asking, tell me what zip folder from CHS you want me to import. Then the second item is what we call the CHS dependencies. These are going to be distributed with our tools, but basically it has all the relevant CHS study metadata that StormSim requires in order to be able to set up the database correctly. That basically stems to, you know, StormSim taking care of making sure that we are accounting for any bias corrections correctly, any datum corrections that are needed, and that sort of stuff. We take that responsibility out of the user and we take care of it ourselves. So making the use of CHS data much easier. But then you have some other stuff like creating alternate databases based on the source data you do provided. Some additional metadata that's tied to the study that you were bringing in. And finally, useful little plot tool that just shows you information that's being imported before adding it to the UI. So in other words, you can go ahead and create a storm database. And if you're, you know, cycling through different storms and it doesn't look right, or doesn't really meet the mark of what you're looking for, you are, you know, in all your freedom to import a new data set and see how that one looks before you actually add it to the project. But once you import it to the project, same as the PSC viewer, things get populated in the main UI, and then you're able to interact with the different items. So you can see that in this case, I defined the storm database as stormdb01, and you can see how it's populated on that drop-down menu. The same that all these little things get updated according to the content of that database. Then we go to the StormSim Run tab, where basically this is where you set up your simulation, right? What workflow do you want to run? What are the specific parameters to that specific workflow? And what are the assets that you want to use for this specific simulation? So on the left side, I put a diagram that I showed on our previous technical discussion, just so you can have an overview of what's really happening under the hood when you click that Run StormSim button. So what's happening is we're taking all this information, structured geometry, we're taking all information about the storm database. We're going through the process of formatting that storm database according to the workflow that we're specifying. So in other words, if you specify a lifecycle project, formatting that or creating that project forcing means I am sampling events from my database to create my life cycles. And then, going through the process of adding any additional adjustments like sea level rise or tides or depth limitation to your waves, but also accounting for uncertainty, which is a very important part throughout this whole process. And finally, going to the exercise of computing the actual responses with all this information being already mapped out. So in this example on the right side, I specified StormSim Pros as the workflow. You can see that I'm using the same, storm database 01. I'm applying depth limitation. I'm limiting things to only tropical cyclones. And then you're also able to limit what specific structure responses you want to compute. Obviously, these are tied to the specific protection system that's being evaluated. So if you notice on the left side, right now is highlighted alternative A under the Mount A PSC. And that's basically what this little tab is interpreting is, oh, okay, you want to use alternative A from this specific PSC according and couple it with this specific storm database in order to compute these different responses. And once all this is set up, you're able to click Run StormSim, and then that whole process gets started up. And then whenever the results are fully parsed out and written, things get populated on the results viewer, which we'll see on the demo because it's easier to showcase. And this is the part where I go out of the presentation and do this. Okay. Things are gonna pop up on the bottom corner because we're still fleshing out that details as to make it pop up in the center. But so we're just gonna go through the whole process from start to finish. Again, remember we have these menu windows that we are using to be able to add or remove elements or assets within our StormSim UI. So I'm gonna start it off by creating a new project. And here I need to define what my project name is. I'm just going to say project B to put something.
Hey, Fabian.
Yeah, go ahead.
This is Kevin. Sorry, I'm not sure if it's possible, but if you can zoom in a little bit, it might make it easier for everyone to see. I don't know if that's a possible thing or not.
I don't know how I can zoom in myself, but I know everybody can zoom in on their side.
Yeah, I see that functionality now in the lower left. So if anybody's having trouble seeing, there's like a little plus and minus in the lower left.
Thank you. I apologize. Let me see if this maybe helps it out a bit. Does that help?
Yeah, it does. Thanks.
Okay, hopefully this works. So yeah, I define it project B. You can see I'm getting a green light. That means in the specific directory that I'm working on, there is no project B. So I'm not overwriting any results. I'm not going to screw anybody over, right? Here, this little tab, if you wanted to allocate your outputs elsewhere, for example, I have this folder that I created called StormSim Projects. I'm just going to tell it, hey, populate the results there. I'm just going to leave the vertical datum, not the 88. This is written value, so you can really put whatever you want there. But not sure why I keep scrolling to the side. Okay. And I go ahead and create a project. that populated the project in my project tree. Obviously, now I need to go through the exercise of adding a protection system, and I'll list them down for the benefit of everybody, because I know the font is a bit small. But basically, within StormSim currently, we support vertical walls, levees, and rubble mounts. So in this case, I'm just going to go ahead and click on rubble mount. And you can see that I get this little PSE window that we saw on the previous slides, right? Where I'm able to add or remove a berm if I wanted to. Obviously, the fields on the tables are updated accordingly if this thing exists or doesn't. But then I'm going to define an alternative name. I'm just going to say alternative A. And then for PSC name, I'm just going to say mount A, right? And, if I'm happy with this specific geometry, I can go ahead and create it. And you can see my PSC viewer got populated. I got all that information on the table. I have it on my project tree. And if I were to add an additional alternative, for example, meaning I want to use the same PSC type, but I want to make some small tweak, right? I can go ahead and create an alternative, and this little window pops up. And it's basically asking me, hey, within your project, tell me what PSC do you want to use as a template for this new alternative. Since I only have mount A, it's going to only show one item, but if I were to have an additional PSC, they would pop up here, right? So I click OK, and this opens the same window. So I'm able to define a new alternative, but you see my PSC name is locked because this is an alternative that belongs to the specific PSC called mount A. So let's say I want to remove the berm, and I'll put alternative B. And then I create it. So now I have two alternatives that are tied to the same PSC. And I'm just as easily able to switch between them through the project tree. You can see how the plot gets updated the same way that I can do it through here. So simple little feature, but very useful when you're trying to cycle through different iterations of the same protection system. So I like it. I find it cool. Also, if you, for some reason, wanted to take this specific geometry plot and you wanted to overlay some extra information and whatnot, or make some annotations for your specific reporting, you can click on that little button and it blows up the figure outside of the UI. So you're able to, interact with it, add any annotations you want, titles, labels, overlay arrows or whatever, which I believe is a useful feature when coming up with intermediate reporting to up the chain or sponsors. Then we can go ahead and add our database, right? So we're going to go ahead and add a Storm CHS database. You have this little button here. If you don't have modeling data, this little button basically opens up the website for CHS, which I know most people here are familiar with it. So first things first, before I'm able to choose a modeling folder, we need to point it towards that CHS dependencies, which again, it's going to be provided with the software and likely be automated at some point. But for now, this is the best route. So once that CHS dependencies folder is uploaded, we have all the necessary information tied to the CHS studies. We're able to go ahead and pull in the modeling data. In this case, I have this labeled as Andrew River Jetties. It's basically tropical cyclone data from the NACCS regional study on CHS. I include both the peaks and the time series. You can see that I brought it in and I'm getting a preview of what's in it. I have things like the study that it belongs to, the vertical datum it belongs to, the safe point depth, and whether or not it has peaks or time series, right? So why is it important for us to list the datum here? Is because, we kind of need to provide a way to the users to be able to adjust the vertical datums in such a way that it matches the project data. Because if they're not in the same datum, the metrics are kind of not, they don't make sense, right? So that's what this little box is here for. These names are obviously populated accordingly. So the NAFD88 comes from the project. Since I defined the project datum to be NAFD88, that's why it's showing there. The same way that since the study has a mean sea level datum, that's why mean sea level is there. So here I can go ahead and define what name I want to use for my specific database. This is obviously generic. You can go ahead and label it with SafePoint IDs if you wanted to, or whatever other naming convention you want to use. You can go ahead and decide whether or not you want to create the alternate data sets that we support within StormSim. I'm not going to do so, and because it takes a little bit longer. But the intent here is a different way for us to match the modeling data between AdCirc and whatever wave model is used for this specific study. So we basically leverage the peaks files and the time series files to create different versions of the database if you wanted to go through that route in evaluating the impacts. But once this is sorted out, I can go ahead and create the Storm database, or in other words, parsing out all the data from the CHS-H5 files and going to the process of matching those two modeling outputs to be able to create the database itself. So I click Create Storm. Now it's going to go to the process, so bear with me. It takes a little bit, but it's not as bad. But basically, you get updated through the whole process. Right now, what's happening is that it's extracting the H5 files and it's scraping all the relevant information within it, all the modeling results for all the storm events and all the associated metadata that comes with it. For this specific study, we're talking about 1,030 something tropical cyclones. So it's processing those 1,000 something events. So in the meantime, are there any intermediate questions while this thing, finishes processing? I don't have the chat window open if anybody's writing anything. Marissa.
Nothing so far in the chat. If you guys would like to post your questions in the chat, you're also welcome to come off mute and ask a question while these things are processing.
Yep. So it's already, finished processing all the H5s, and this thing that's popping up right now is matching the AdCirc and the wave model data.
Hey, Fabian, this is John Winkelman. While we're waiting, with the use of the CHS data, so easy, and we're lucky enough to where we have save points or sorry, I'm kind of listening to two presentations here. It sounds like we might be able to just pull nodal data at some point from CHS versus the save point data, so maybe it's less important. But if we have a distance between the data point that we're using and the structure, where there might be some wave transformation and things like that, or are you guys thinking about the best ways to handle that? Do we, pre-run or pre-transform that data from CHS to the project location and then run it through this, or would it be okay to put a simple wave model in between or something?
That is a very, very good question, and the answer is both are fine, right? In the UI environment right now, it's kind of locked to our specific function for handling forcing adjustments. But if you wanted to make those types of modifications to the modeling data, you are more than free to do so, right? StormSim is only concerned with the format of the data. What you do to it, it doesn't really care. So, for example, Jeff Melby in the past has done that type of approach where he takes the database once it's created and injects it to some other process to be able to transform those waves to the top of the structure and then reinsert that into StormSim. So definitely possible to do so, and would be a great addition to include in the UI environment. So thanks for bringing it up.
All right, thanks.
So here you can see that the plot got populated. So what happens once the database is created is that you'll be able to see what's stored within it. So in this case, we are looking at the peaks, and all it's doing is just plotting the peak response for all these storms that are within the database. So in this case specifically, we're looking at the water level, but say you wanted to look at the wave height, you can do that as easily. Peak period, do that as easily. It doesn't look as pretty, but let's say if you wanted to look at time series, you could do so. And you can see that the Storm ID drop-down menu gets enabled, so you're able to cycle through all the events that are within the database and see what that hydrograph looks like. The same way, you can pull out this little thing if you wanted to overlay things like, I don't know, the crest elevation of this specific protection system, because you want to see how the storms compares against it. You can do that here. The same way, if you wanted to get a better look at the table, you can see, here I'm looking at all the time steps that are tied to this specific storm event and that specific response. So just little things that make it easier for a user to interrogate things midpoint or be able to pull data off for whatever other reporting thing they have going on. So that's really the main aim of this whole process. But once this is all said and done and you're happy with it, you're able to import it to the project. Same thing, the plots get transferred, has the same level of functionality. You can pop out things, you can pop out the table, you can switch through things here, and switch the storms and all that good stuff. And now onto the StormSim Run button. Here, you can see that I'm only showing one database, but all the databases that I create will be showed up here. I'm going to turn on apply depth limitation. Like I mentioned earlier, I'm only working with tropical cyclone data, so storm sampling is limited to that. But if you had both storm types for the NICCS study, here you would see tropical cyclones, extratropical storms, and you could also do a combined storm sampling, meaning in the context of StormSim Pros, we get the hazard curves for extratropical storms, the hazard curves for tropical cyclones, and then we combine both into a combined hazard curve for each response. So I'm going to leave this as is, no sea level change. This little button is if you want it or not to compute the forcing hazard curves, because again, the forcing hazard curves are something that you can get directly from CHS. But nonetheless, if you wanted to compute them, you can do so here. You can specify your preference of using AEP versus AEF for those outputs. And then you can specify here what are the responses you want to compute for this specific protection system. And if you want to use all the data types that are within your database, I'm going to say yes. I'm going to turn this off. And I'm going to run it. So same thing. This shouldn't be as bad. But I'm going to bring this little window here. Oh, of course. So this is going through that workflow that I showed earlier, where it's taking all the information that's been mapped out through the UI, the geometry, the storm database. It's reformatting that database according to the workflow you specified. Is accounting for the uncertainty that's needed in order to be able to compute the responses within our probabilistic framework. And then it's going to go ahead and compute the actual responses. And we'll see in a progress update popping up on the command window shortly. I just had to close that progress bar to be able to interact with the window on the back. But we're almost done. I promise. And I think we're good. We're good on time. So.
Any other questions from the field?
You can here you see the pop-up. It's telling me, hey, I'm running StormSim Pros. I'm using the peaks. It's going through the process of computing each response and passing those to our joint probability method to be able to come up with the hazard curves. And it's doing the same thing for the time series. And then once that's done, this hasn't finished. Okay. Once that's done, you'll see this will get populated.
Hey, Fabian, there's a question in the chat. So
Sure.
when this product is ready to be distributed to end users, will that be through a compiled standalone executable or through a collection of .m files to be run through the user installed version of MATLAB?
That is a great question. We are exploring all alternatives, right? The intent is that we want to be as accessible as possible. So currently the way it's set up is we can either go through the route of a standard MATLAB application, meaning you can actually install it into your MATLAB toolbar, the same way that we could go the executable route, the same way that this could just be a .m that you run, and it's just, picking all the relevant functions as needed. It's loading the resource in. There's zero interaction, zero expectation on the user to understand, hey, these are all the scripts I need to call. But to that end, and I'll mention a little bit this in the closing remarks slide, in an effort for us to be more accessible, we are looking towards migrating this whole thing towards Python. And there are currently ongoing efforts for that. We're looking into contracting options and whatnot, and Kevin Hodgins is on the line if anybody wants more details on that later on. But that is something we have in our purview, right? We want to make it accessible and as easy as possible to get it on people's hands. That being said, when this is finished and we're ready to roll it out, our first engagement with interested collaborators is to have like a mini workshop on this. It's basically going to be the similar exercise where we have the tool, we have people that are interested on it, run it on their machines, go through the whole exercise of setting things up, follow it up with a feedback session, because even though, we have a lot of cool stuff that we can output in terms of the results, we would like to get a better sense as to what the districts are really interested in terms of reporting metrics, right? I have this project, I have all this data. How do I condense it down? What are the stakeholders actually interested? What information is relevant? That's the area where we need feedback from our partners. So looking forward to that in the future.
Okay.
So, yeah.
With the way that it currently is in MATLAB, does it require any special MATLAB packages or just base MATLAB?
The only one would be the stats toolbox.
Okay.
That's pretty much it.
Okay. Thanks.
No problem. So final tab, you can see here the results. As I mentioned, they're going to be hazard curves because we're running pros. But you can see here we'll have different plot types, but for this demonstration, I just focus on hazard curve. But same level of interaction, you can specify time series, peaks, the same way that you can specify the different matching types if you account, you included those in the creation of the database, but you can switch between different responses like overtopping discharge rate or still water level if you wanted to look at that hazard curve or runout, And the same thing, you can pop it out, make your annotations. You wanted to look at the table data. That one didn't work. But okay, you get that. It's the same thing. And that's basically it. That's the UI. Again, you can see that the main focus is just basically mapping data and streamlining the process for the user to be able to set up the software, right? Instead of having to, be greeted with this and just to make a point, right? Instead of coming to this, right? I give you a tool and I tell you, hey, here's the config file and populate all this out according to your needs. It can be a bit daunting, right? And then making sure that you're defining things correctly, like, oh, this is my PSC name, this is my project name, this is my alternative, So a lot of the effort was focused on that, just populating this thing easier. and allowing the users to be able to dynamically switch between the different options. So a little bit of closing remarks. Like I mentioned, the UI is well on its way to be finished by the end of the year. We're around 80% complete. A lot of the stuff that's left over is mostly like ironing out some kinks as to when a user adds or removes a certain thing or switches this menu. It's more of sanity checks more than anything, but nonetheless, it needs to be done. As I mentioned earlier on, we took a big hit in our PDT for this effort, so the StormSim team is definitely looking for interested district partners that want to provide any kind of feedback in our tools and our UI development. As I mentioned earlier, any missing metrics or additional metrics that you guys would like to see come out of StormSim, or if there is a specific project that you would like to see StormSim be applied on, in this case, in a previous project kind of sense. I'm not sure we have the bandwidth for new projects, but we can definitely confirm that with Kevin or you, whoever can tackle that on. And obviously, participation on that StormSim version 1.0 release workshop. And some notes as to looking ahead, I mentioned earlier on, there are ongoing efforts to convert our tools to Python. The same way there are efforts ongoing to be able to provide a StormSim solution to the West Coast. And in the future also, we would like to see supports of new protection system elements, because again, depending on the structure system you're evaluating, we might need to add a new alternative or protection type within StormSim, but that's a TBD. And yeah, that's pretty much it. Any questions? If you want to reach out for any additional information, these are most of the team members on the StormSim development in one sense or another. So anybody would be happy to answer your questions.